Good morning, students. Now we will discuss short circuited transmission line. Short circuited transmission line that we will discuss right now. In case of short circuited transmission line, we have a condition, that is simply ZL is equal to 0. ZL is equal to 0. The condition is ZL is equal to 0. That means whenever we are having a transmission line like this, generally here we are connecting load. Now in case of short circuited transmission line point of view, this will be 0. Short circuited, that is here the ZL value will be 0 in case of short circuited transmission line. So the condition is here, ZL is equal to 0. Now similarly we know that input impedance. Now I am dealing with short circuited transmission line, so I am writing this one as ZSC, short circuited transmission line impedance. ZSC equal to, we have general formula, Z0 into ZL cos H gamma L plus Z0 sin H gamma L by Z0 cos H gamma L plus ZL sin H gamma L. It is the general formula we have. Now here the value of ZL is 0. In case of short circuited transmission line, the value of ZL is equal to 0. So substitute the value of ZL 0 here by substituting Z0 into 0. ZL means 0. 0 cos H gamma L plus Z0 sin H gamma L by Z0 cos H gamma L plus 0 sin H gamma L. That is equal to Z0 into, here this one 0 and the rest of the term is Z0 sin H gamma L by Z0 cos H gamma L. Z0 get cancelled. Then ZSC is equal to Z0 into sin by cos, that is tan H gamma L. It is ZSC equal to Z0 tan H gamma L. That is input impedance in case of short circuited transmission line. Similarly, we have to find the values of reflection coefficient and standing wave ratio. Again we know that reflection coefficient K equal to, general formula is ZL minus Z0 by ZL plus Z0. Then here the value of ZL is 0. In case of short circuited transmission line, the value of ZL is equal to 0. Then K is equal to 0 minus Z0 by 0 plus Z0, that is equal to minus 1. That is K is equal to minus 1. In case of short circuited transmission line, the value of reflection coefficient K is minus 1. Similarly, we know that voltage standing wave ratio VSWR is equal to, S is equal to 1 plus mod K by 1 minus mod K. That is equal to 1 plus mod K means K value is here minus 1. Mod K means mod minus 1 by 1 minus of mod minus 1. That is equal to simply 1 plus 1 by 1 minus 1. That is equal to 2 by 0. That equal to infinity. that is simply S is equal to infinity. In case of short circuited transmission line, the the VSWR is infinity. In case of short circuited transmission line, the reflection coefficient value K equal to -1. So VSWR is infinity. Now we have to draw the plots for the short circuited transmission line. To draw plots for the short circuited transmission line, we had to use this equation. So I'm considering it equation number 1. Now we had to use this equation to draw the plots of the short circuited transmission line. Now I'm considering equation 1. Consider equation 1. The equation 1 is this, that is ZSC equal to Z0 into tan H gamma L. It is from equation 1. Now, in case of lossless transmission line, we know that in case of lossless transmission line point of view, we have already derived alpha equal to 0 and beta equal to simply J, beta is equal to omega root L C. Those are the two expressions we have derived in case of lossless transmission line. Now here we need only this one, that is alpha equal to 0. That means we know that gamma equal to alpha plus j beta. Here the value of alpha is 0. Then I am writing gamma equal to j beta. Now I am substituting this gamma equal to j beta here. Here I am substituting. Then it will become ZSC equal to Z0 into tan H. Gamma is nothing but J beta L. Now I am converting this hyperbolic function into normal function. That means by converting this into normal, it will become ZSC is equal to J Z0 tan beta L. Here this hyperbolic is converted into normal. Hyperbolic function is converted into normal tangential function. Now assume with this equation we have to draw the plots of the short circuited transmission line. By considering different values of L, we have to draw the plots. Here the value of beta is 2 pi by lambda. That is, here beta is equal to 2 pi by lambda. It is the point. Now I am constructing the table to plot. Now let us I am assuming it is a length and it is beta L. Here is L value, beta L value. Here is ZSC value. I'm designing the table for this one. First, I'm assuming L value 0. So beta L is nothing but beta is here this one 2 pi by lambda into L is nothing but 0. That is equal to 0. In the first case, when L equal to 0, beta L equal to 0. Then ZSC equal to, the formula for ZSC is here, J Z0 tan beta L. Here we have a value of beta L. Now I am substituting that value here. So ZSC equal to J Z0 tan 0. We know that tan 0 value equal to 0. Then j z naught into 0. That is ZSC value will be 0. In the first case, that is at L equal to 0, beta L is equal to 0. ZSC equal to 0. That is the first assumption. Now I am assuming the L value as lambda by 4. Now the length of the transmission line is lambda by 4. Then beta L becomes, beta is nothing but 2 pi by lambda into L is nothing but lambda by 4 equal to, here lambda get cancelled, 2 2's. That is we are getting pi by 2. The value is pi by 2. Then ZSC is equal to j z naught tan beta L. Here the value of beta L is pi by 2. So j z naught tan pi by 2. We know that the value of tan pi by 2 is infinity. So this value will become infinity. In the second case, when L equal to lambda by 4, Zs value is infinity. Now the third case, I am assuming L is equal to lambda by 2. Now beta L, beta is nothing but 2 pi by lambda into L is nothing but lambda by 2. 2 cancel. Here is pi, beta L is pi. Then ZSC equal to jz naught tan beta L, that is equal to jz naught tan pi. We know that tan pi equal to 0. So this value will become 0. And in the next case, I am assuming the L value will be 3 lambda by 4. 3 lambda by 4 I am assuming. Then beta L is nothing but, here it is L, beta is nothing but 2 pi by lambda into L is nothing but 3 lambda by 4. 2 2's lambda, that is equal to 3 pi by 2. 3 pi by 2 we are getting. Then ZSC is equal to jz naught tan beta L, that is jz naught tan 3 pi by 2. The value of tan 3 pi by 2 is infinity. So ZSC is infinity. Now these are the 4 cases we are assuming. In the first case, L is 0. In the first case, look at here, these are the 4 cases. L is equal to 0, beta L 0, ZSC 0. L equal to lambda by 4, beta L equal to pi by 2, ZSC equal to infinity. L equal to lambda by 2, beta L equal to pi, ZSC equal to 0. L equal to 3 lambda by 4, beta L equal to 3 pi by 2, ZSC equal to infinity. With these values, now I am drawing the plot. Now I am writing the summary here for L value, beta L value, ZSC. In the first case, L equal to 0, beta L value 0, ZSC value 0. When L equal to lambda by 4, beta L is equal to pi by 2, here is pi by 2, and ZSC equal to infinity. When it is lambda by 2, beta L is pi, it is 0. And it is 3 lambda by 4, beta L is 3 pi by 2, and ZSC is infinity. Those are the values we got for the corresponding expression. Now we have to draw the plot. Now look at here. Now I am drawing plot like this. Here on the x-axis I am assuming beta L. On the y-axis I am assuming ZSC. That means this value on x-axis, this value on y-axis. Now I am letting the beta L ranges. Initially 0 is 0, the next value is pi by 2, the next value is pi, next value is pi, next value is 3 pi by 2. I am assuming it is a 3 pi by 2 up to so on. The next value will becomes 2 pi. Like that we are having different values of beta L. Just look at here it is beta L. Initially beta L value is 0, next pi by 2, pi, 3 pi by 2, next value will comes as 2 pi. And next, when we seen here 0 to pi by 2 is the first quadrant, pi by 2 to pi is the second quadrant, pi to 3 pi by 2 is the third quadrant, 3 pi by 2 to 2 pi is the fourth quadrant. In case of first quadrant, tan value is positive. In case of second quadrant, tan value is negative. In case of fourth quadrant, tan value is positive. Fourth quadrant, tan value is negative. Because we have considered here tan values, because here our expression is in terms of tan, ZSC equal to JZ naught tan beta L. So we have considered the expression in terms of tan. With this, now the values. When beta L equal to 0, ZSC equal to 0. That means beta L 0, ZSC 0. It is the point. That is the point. Next, when beta L equal to pi by 2, ZSC is infinity. When beta L equal to pi, beta L value it is this, pi by 2 is this. At this point, ZSC is infinity. That means when we consider if it is less than pi by 2, that means in the first coordinate it will become plus infinity. If it is plus pi by 2, that means it will comes into second quadrant. In second quadrant, tan value is negative minus infinity. It is a point, minus infinity. It is a plus infinity, it is a minus infinity. Here we have represented in the first quadrant because tan is positive in the first quadrant. Now at beta L equal to pi, its value is 0. It is the point. At beta L equal to 3 pi by 2, it is infinity. That means again at this point, that is infinity. And while coming to this one, 3 pi by 2, when the value is less than 3 pi by 2, then it will be third quadrant. In third quadrant, tan value is positive. It is a point. When it is greater than 3 pi by 2, tan value is negative. It is negative value. So when we plot, it is first point like this, and second point like this, third point like this. It will be repeats like this. These are the waveforms that we are getting in case of short-circuited transmission line. At this point, when we seen this, between 0 to lambda by 4, that means 0 to pi by 2, all the values are positive. 0 to pi by 2, all the values are positive. It is positive values, it is negative values, it is 0. All the values are positive. That is, we can say that 0 to lambda by 4, the short-circuited transmission line acts as inductor. Important point. 0 to lambda by 4, the short-circuited transmission line acts as the inductor. When we are having here positive values, those are inductors. When we are having negative values, then the short circuited transmission line behaves as a capacitor. When there is no value like this, then the short circuited transmission behaves like a open circuit. When it is 0 like this, then the short circuited transmission line acts as a short circuit. And in the second case, inductor is over. Now look at here, this one to this one, pi by 2 to pi. That means in between lambda by 4 to lambda by 2, when the length of the transmission line is from lambda by 4 to lambda by 2, lambda by 4 to, look at here, lambda by 4 to lambda by 2. That means pi by 2 to pi. Look at here, pi by 2 to pi. Here the entire values are negatives. Then short circuited transmission line acts as a capacitor. Within the duration lambda by 4 to lambda by 2, the short circuited transmission line acts as a capacitor. And at the same time, at L is equal to lambda by 4, at only at L is equal to lambda by 4. That means lambda by 4 means pi by 2. Look at here, lambda by 4 means pi by 2. That means at this point there is no line, so this short circuited transmission line acts as a open circuit. Short circuited transmission line acts as a open circuit. At L equal to lambda by 2, that means lambda by 2 means beta L value pi. Look at here, the value of pi is here, the line crosses, so it acts as a short circuit. At L equal to lambda by 2, the short circuited transmission line acts as a short circuit. These are the points you have to remember while discussing to any short circuited transmission line. Like this, in the same way we have to do for open circuited transmission line also.